In this problem, we are asked to find the equation in x and y whose graph contains the points on the curve, where x is defined to be 2 squared plus 1 and y is defined to be t squared minus 1, for t taking on the values from negative 2 to positive 2. We're also asked to sketch the graph and indicate the orientation. We will recognize that both x and y are in a quadratic form. Therefore, one way we could sketch the graph is to let t vary from negative 2 to positive 2 and determine our values for both our x and our y. So if x is equal to negative 2, I'm going to get negative 2 squared, which is 4 plus 1, or 5. In my y function, if t is equal to negative 2, I'm going to have 4 minus 1, or 3. I can continue on in this process, plugging in t ranging from negative 2 to positive 2 for each one of my x functions, likewise for my y functions. I could then take a quick sketch of my graph with my x and y axes. The first point that I will graph is my x values and my y values. So when x is equal to 5, y is equal to 3. When x is equal to 2, y is equal to 0. And when x is equal to 1, y is equal to a negative 1. And then it goes back. When x is equal to 2, y is equal to 0. And when x is equal to 5, y is equal to 3. We will see this as a linear function where as t increases, our x values and y values start to decrease, and then they increase again. Therefore, our direction can be written as 2 arrows. To find the equation, we could solve for one of these in terms of the other. I would see that I know that y is equal to t squared minus 1, or t squared is equal to y plus 1. I could go ahead and plug in t squared into my equation, where x is equal to t squared plus 1. Therefore, I get x is equal to y plus 1, or x is equal to y plus 2. Again, this is an equation of a line that has a slope of 1 and passes to the point y equal to 0, x is equal to 2. Another way I could write this is in terms of y equals, or y is equal to x minus 2. Again, giving us a slope of 1 and a y, or this time, an x-intercept at 0, negative 2.